So here I'm going to go through an example of solving a system, in this case it's just a mixer, using our material balance equations and going and solve for unknowns. So when we have a chemical process, we usually will have like some text, maybe a paragraph or two describing that process. And our job is to take that text from the problem statement and convert it into a flow diagram. And I've gone ahead and skipped most of that step here. I've just shown you the flow diagram and variables for various unknowns here in this flow diagram, but that'll be part of your job for the homework problems and test problems, etc. You need to go ahead and make a flow diagram. But again, let's just assume we have a flow diagram. So what do we have here? We have three components, A, B, and C. So we have three components, and we have an inlet stream here, which I've labeled M1. And so M1 is the flow rate in mass of this stream, and then we have the mass fractions for the three components right here. So the only unknown variable for this stream right here is the flow rate, the total flow rate of that stream. Then we have here a second inlet stream, and this stream is pure A. So we only have pure A in the stream, and the flow rate of this stream is also unknown. So I've labeled this M2, that's the flow rate of this stream in the grams of A per second, so it's a mass flow rate. And then finally we have here, leaving the system, details about the outlet stream. We know the total flow rate, so that's information that was given to us, and we know the mass fraction of B, but we don't know the mass fractions of A or C. And so in total we have here four unknowns, M1, M2, X, and Y. And so those are the unknowns we're trying to solve for. Now, at this point, it's very smart to consider how we're going to go about doing this. So we think about what equations we're going to need to solve this. And more or less, there's two types of equations that we need to solve this problem. One are our material balance equations, and two are our equations that relate the relationships between mass fractions. So in this case, we're dealing with mass fractions right here that are unknown in our outlet stream, and we're dealing with mass flow rates. So that tells us that we're probably going to need some equations to go ahead and solve for these unknowns. Before I even do that, however, I'm going to go ahead, just so it's clear, I'm going to write out what unknowns we have. So these are the things we're trying to solve for. M1, M2, X, and Y. And the big reason I do this because it helps me keep on track. When we have large problems that may involve 10 different variables or 5 different variables or 15, whatever it is, when we're dealing with systems with a large number of variables, it's easy to get lost and confused about what you're trying to do. And so just by writing out what are the unknowns I'm trying to solve for, put a nice box around that, it's clear in my mind that this is what I'm trying to get at. This is the goal of me trying to solve this problem. Let me just shrink that down there. And so that's what I'm trying to solve for, these four unknown variables. The other thing that I can do is I can write out equations that are going to be useful for this. So let me write this here. That's a Q, not a G. Equations. And so by writing out the equations that may be relevant to this problem, that helps me better and much easier solve this problem, because then I'll have a listing of the tools that I'm going to use to solve for those unknowns. So the first thing that I'm going to write out is the material balance equations. So the sum of the mass fractions, Wi equals 1, and then if I just write out that in detail, that's X plus 0.1 plus Y is equal to 1. So that's our mass fraction equation for that particular system. I have the outlet stream, so I just take all these and they should all add up to 1. The other thing that I need to solve for, again, are these flow rates here, M1 and M2, so it's good to have the material balance equations. So let me go ahead and write out this. Let me go ahead and write a total balance. So M1 plus M2 equals 400 grams per second. And I notice how I wrote my units here. Gotta always keep the units. There's no units here up here because mass fractions and mole fractions I could have written out as that is grams per gram, but we're okay usually for mass and mole fractions and without writing the units on them. That's probably one of the few exceptions in the class where we don't worry so much about writing out the units. Next, I'm going to write out the balance on A. So M1 times 0.3 plus M2 is equal to 400 grams per second times X, and then I got a B and a C balance. M1 times 0.2 is equal to 400 times 0.1, that's grams per second, and then C balance M1 0.5 is equal to 400 times Y. And so again, I'm just looking at inlets and outlets and making sure whatever goes in comes out. So for A, I just took M1 times 0.3, and that will tell me how much A is flowing in this stream here, and that's what I got right here, plus M2, which is pure A, is equal to the amount leaving, which is 400 times X. That's where I get this 400 times X here. And I just did the same thing for the B and the C. In this case, we only have B coming in stream 1, we only have C coming in stream 1, and then we have the flow rates multiplied by the mass fractions there. And now I'm in pretty good shape that I can go ahead and start trying to solve this problem. So let me go ahead, and I see off already, just looking at these equations, that in this equation right here for the balance on B, there's only one unknown variable, M1. So that's good. So I can go ahead and solve this for M1 real easily, and I'm going to do that. So let me just write here, here's my solution. M1 0.2 is equal to 400 grams per second, 0.1. And if I go ahead and rearrange this and do my algebra for M1, I get M1 is equal to 400 grams per second, 0.1 divided by 0.2, M1 is equal to, M1 is equal to 200 grams per second. Excellent. That's one of the unknowns that I was trying to solve for. There's M1, here's the M1 solution, so I'm definitely going to put myself a little box around that, put a circle, and I have it. I have M1 now, and that's great. And I can, let me just shrink this down here a little more. I can go ahead and look at my material balance. Here's my total balance equation here, and I know M1, I just found it, so now I only need to solve for M2. So M2 is pretty easy. M2 plus M1 is equals 400 grams per second. And if I go ahead and solve that, M2 is equal to 200 grams per second. Excellent. Again, that's one of the unknowns I'm trying to look for, so I go ahead and circle that. And now I just have two more variables to solve for, X and Y. Well, I am going to look here at my A balance, and right now it's a... So next we're going to look at our A balance, but everything's getting a little cluttered here, so let me just pop into a new screen. Things are getting clustered here again, so here I am to a new screen, and I have my balance, my flow diagram there, and again, we already solved for M1 and M2, and those are 200 grams per second. We just solved that on our previous work, so now we're just trying to solve for X and Y. Our A balance, just to remind you, is M1 times 0.3 is equal to plus M2 is equal to 400 grams per second, and that's multiplied by x. So this is great. The only unknown variable I have to solve for in this equation, this material balance equation, is x. And I can go ahead and solve for that. X is equal to 200 grams per second times 0.3 plus 200 grams per second. And this is all divided by 400 grams per second. And x is equal to, x is 0.65 grams of A per gram. And that's one of my ones I'm looking for. Make sure I circle that. And we're almost done. We just have to solve for y. And y is a lot more straightforward because we don't have to worry about any sort of material energy balances. Just give myself a little room here. The only thing we need to solve for with y is to use our mass fraction equations, where we know that 1 is equal to x plus y plus 0.1. I know what x is, I just don't know what y is. So if I go ahead and solve this for y is equal to 1 minus 0.1 minus 0.65, then y is equal to 0.25 grams C per gram. And I go ahead again and circle that. Let me just circle those just for completeness. So now I have it. I have all my unknown variables, and what I did is I just systematically went through and took the equations for the material balances, took the equations for the mass fractions, and solved this. And this is really the gist of what we do when we solve our material balance problems, is we take those material balance equations. They could be moles, they could be mass, it just depends on the problem. Oftentimes we'll take our mass or mole fractions equations into account if that's what we're working with. Again, this problem we worked with mass, but sometimes we might work with moles. It's the same concept where we have moles instead of mass fractions. But that's the basic setup again. So just remind you, pay attention to those material balance equations, go through a systematic process, make sure you draw your flow diagram, identify your unknown variables, identify your equations, and then use those equations in the right order to go ahead and solve for what your unknown variables are. There you go.